And so taking a look at the periodic table, we can get the information about atomic number for nitrogen and oxygen. And those are atomic numbers 7 and 8, respectively. And then phosphorus is underneath nitrogen. Its atomic number is 15. And we have the same number of electrons as protons. So to get the number of neutrons, you say the mass number minus the number of protons. So they'll give us 7 neutrons for nitrogen 14, whereas nitrogen 15 will have 8 neutrons. So that's the difference between those two isotopes of nitrogen, is the number of neutrons, is what makes them different from each other. Same thing in comparing oxygen 16 to oxygen 18. Oxygen 16 has 8 neutrons, whereas oxygen 18 has 10. And then phosphorus 31 has 16 neutrons. You obtain that by taking 31 and subtracting 15 from it. So in the example here that follows, we're given 2 isotopes of silver. Silver 107 and silver 109. And we're given the percentage abundances of each. And so we want to calculate the average atomic mass for silver. So it's going to be equal to the mass number of each isotope multiplied by their fractional abundance, which we'll get by taking the percentages and converting them to decimals. So silver 107's fractional abundance is 0.518. Silver 109 has a fractional abundance of 0.482. And so we simply do the math. This one was an even easier one than the carbon, because for silver, there are only 2 isotopes. And there are a lot of elements that only have 2 isotopes. But then there are some that may have even more than 3 isotopes. They may have 4 or 5 isotopes. So it just all depends on the element as far as how many isotopes there are. So do the calculation. And once you finish your calculation, someone can post their answer in the chat box for us, please. Thank you, Ewan. 107.964. And again, our units will be grams per mole. How does this compare with what's on the periodic table? Pretty close. So now that we've talked about mass, and we know that we can obtain the atomic mass for all the isotopes that exist for an element from the periodic table, and atomic mass is in units of grams per mole. And we've also previously talked about the concept of molar mass for a compound. So when we're talking about an element, we talk about it in terms of atomic mass, the mass for an atom of that element. But then when we're talking about a compound, which is composed of atoms that are chemically bonded together, we compute the molar mass, which is the sum of the atomic masses of all the atoms that are part of that compound. Just like the units for atomic mass are grams per mole, molar mass of compounds have units also of grams per mole. Therefore, if we know the mass of an element, we can calculate the number of moles of that element by using the atomic mass as a conversion factor, because the units of atomic mass are grams per mole. So therefore, we can take the mass of an element and convert to the moles of that element by dividing by the atomic mass. And then we can go in the opposite direction. We can take moles of an element and convert back to mass of an element by the atomic mass. So the atomic mass can be used as a conversion factor to convert between mass in grams and moles. And we can use the molar mass of a compound to convert between mass of a compound and moles of a compound. And we can go in the opposite direction. Converting moles of a compound to mass of a compound by multiplying by the molar mass. And so the concept of the mole, a mole is defined as the number of carbon atoms in exactly 12 grams of pure carbon-12. And so this is known as Avogadro's number to define 1 mole of something. 1 mole is equivalent to 6.022 times 10 to the 23rd. And for unit purposes, I'll use the word entities. And you say, well, what can an entity be? And my answer to that would be anything. 1 mole of anything is 6.022 times 10 to the 23rd. And so therefore, 1 mole being equivalent to 6.022 times 10 to the 23rd. That is called Avogadro's number. And so we can say 6.022 times 10 to the 23rd entities per mole. Those entities can be atoms. Or if we're talking about an element, or if we're talking about a compound, the entity is a molecule. So the units for Avogadro's number can either be atoms per mole or molecules per mole. So just like we could use atomic mass in grams per mole or molar mass in grams per mole as a conversion factor to convert between mass and moles, we can also use Avogadro's number as a conversion factor to convert between moles and atoms or between moles and molecules. If we're talking about a compound, then that would be molecules. But if we're talking about an element, of course, that would be atoms. So again, to review, to convert between grams and moles or between moles to grams, use molar mass or atomic mass. To convert between moles and atoms or moles and molecules, use Avogadro's number as a conversion factor. And so in using atomic mass, if we're talking about an element, as a conversion factor to convert between grams and moles, and then we can use Avogadro's number to convert between moles and atoms, or between moles and molecules if we're talking about a compound. Let's answer a few questions that are going to require us to do some calculations. So if I have 36 grams of carbon, how many atoms of carbon do I have? Well, if I look at my flow chart here, I've got 36 grams. So I'm going to start here. I'm starting with grams. But the question is asking me how many atoms do I have? So I've got to go from grams to moles, and then from moles to atoms. So I have to do a two-step calculation to answer this question. So first I take my 36 grams of carbon, and I'm going to use the atomic mass of carbon to convert the grams of carbon to moles of carbon. So with our conversion process, which we learned in chapter 1, I want to get rid of grams and convert them to moles. So I'll put grams in my denominator because that's the unit I want to get rid of. I'm going to put moles in my numerator because that's the unit that I want. And so now I look up the atomic mass for carbon, which is on our periodic table. It tells us it's 12.011 grams per mole. So the grams cancel. And we do the calculation. And that will give us the moles of carbon. But we don't want moles of carbon, we want atoms of carbon. So once we get the answer for atoms, for moles, we'll take the moles of carbon and we'll convert the moles of carbon to atoms. So again, our conversion of units process, the unit that we want is atoms. So it goes in the numerator. The unit we're getting rid of is moles. So it goes in the denominator. And our conversion factor that we need to use is Avogadro's number, which is 6.022 times 10 to the 23rd atoms per mole. So the moles cancel. So how many moles of carbon do we have? Did someone give us our calculation for that? I've already set it up. Can someone do the calculation for us, please? 36 divided by 12.011. So we got 2.99 moles. And then we take that 2.99 moles and convert them to atoms by multiplying by Avogadro's number. So how many atoms do we have? Anyone have that value?
1.80 times 10 to the 24th.
Thank you. So we have 1.80 times 10 to the 24th atoms of carbon. Any questions about that example? So we saw we had to do a two-step conversion. Now you could have done it all in just one single long calculation, or if you're not feeling Very, very confident. You may want to just do it the way I did it in 2 separate steps and piece it together. The next example, we have 8.9 times 10 to the 24th atoms of carbon. So we're starting here at atoms, and we want to convert those atoms to grams of carbon. So we've got to calculate backwards. So therefore, in calculating backwards, we're going to convert the atoms to moles. That's our first step. And then moles to grams. That's our second step. So again, we've got a 2-step calculation, but this time we're going in the backwards direction. So we're getting rid of atoms. And we're converting the atoms to moles. So we're going backwards. And then we're going to convert the moles to grams. And so to do that, we need Avogadro's number to go from atoms to moles. 6.022 times 10 to the 23rd atoms per mole. The atoms will cancel. And so we'll get moles of carbon. And then we'll take the moles of carbon and convert them to grams by using the atomic mass. Of carbon. The moles of carbon will cancel, and you'll get grams of carbon. So I'm going to let you finish that one. And then we will resume with these last 2 examples. And we'll resume with these last 2 examples on Monday of next week. And so again, on Wednesday at 11 a.m., there's the college's second activity hour of the semester taking place between 11 and 12. So we'll only have a short 15 to 20-minute lecture on Wednesday, and I'm going to lecture on molecular shapes because that is the subject of your lab this week. And then Monday, when we return to our normal class length, we'll pick up right here in answering how many grams of carbon are in 100 grams of CO2. And so we'll learn how to do that type of calculation and conversion after we discuss the answer to the second example. And then we're going to go on Monday and talk about significant figures. And we will then have another set of questions to answer. I will have part 2 of the chapter 4 notes up in eLearn sometime tomorrow. And again, as I discussed with you earlier, we are reporting midterm grades this week. Your midterm grades will be calculated as such using those components listed. And I will have your midterm grades posted sometime before midnight tomorrow night. My deadline is by noon on Wednesday. And so usually when I have like a noon deadline, I like to get it done the night before. And so I should have your midterms posted to the grading system by midnight tomorrow night. Have a good rest of your Monday. And if you do not attend the little short 15-minute lecture on Wednesday, I will be recording it and I'll post it in eLearn on our lecture site under chapter 4 where the notes are. If you have any additional questions, you can hang around in the meeting room after class. If not, have a good Monday.
Hi, I just had a question about an email that I sent you the other day. I don't know if you saw it or not.
Yes, who am I speaking with?
My name is Gabrielle Upshaw.
Hi, Gabrielle. Do you need this to be private?
Probably yes.
Okay. We still have a couple of other students on the line with us. If you want to call me, you can call me at my office number, which is 423-697-3229.
Okay, I'll call you in just a minute.
Okay, thank you.